Hello friends! I've decided to start reviewing some PEDs on this channel every so often. You'd be surprised, I do get quite a bit of questions about my opinions on different PEDs. I think the reason is of course not due to any particular success I had using PEDs myself, but I think that people know that I'm pretty interested in the pharmacology of different kinds of drugs, and so maybe I have some opinions either from my own experience or from my readings. So today I thought I'll start with one that I'm not very fond of and I have a particular opinion about, which is boldenone, or also called Equipoise. Actually, it also has other brand names, but anyway, Equipoise is quite interesting because Equipoise is not very well studied at all. It's mostly studied in odd animals like chickens and of course horses. Equipoise has been used extensively in the doping of horses. There are some, so for this video you're going to find a blog post linked below in which I have citations for everything I say. The blog post will have just brief notes of what you can find in each article if you want to check it out. To be honest, it's not very useful. As I said, it's not very well studied, so most of what I tell you here today will be from my own personal experience, which is quite extensive. I've used the Equipoise quite extensively in the past, and I have particular opinions on its value. So let's begin with what we know from the research. Number one, I've also written some notes here. So number one, what we know is that it has an affinity for the androgen receptor that is greater than testosterone's. But so dihydrotestosterone has a 100% affinity for the androgen receptor. Testosterone has a 31% affinity. Excuse me, my dog is getting excited. Someone's probably outside the door. Testosterone has a 31% affinity. And Equipoise has a 49% affinity. Now, what this really means is, basically it means that if Equipoise is in an equal concentration with testosterone in the body, and there's enough Equipoise to cover all the androgen receptors, testosterone will never bind to the androgen receptor unless they're binding at different binding sites, which we don't know if they are or not. That is a possibility, by the way. So some receptors, I'm not talking about hormone receptors in particular, I'm not really an expert on those, but there are some receptors in the body, like in the brain, receptors have different natures. So I won't get into too much detail, but basically a receptor can have different sites of the receptor at which a hormone or a drug binds to and activates the receptor, allowing it to, for example, get calcium through it or chloride or something like that. So if there's more than one binding site, it's possible that you can have a great affinity for one drug and a lesser affinity for the other drug, but both bind to it and both activate it at the same time. So they co-activate it. So I don't know if that's the case with Equipoise and testosterone. There are no studies on this, but I assume it's not. I think they most likely, because their molecular structure is extremely similar, they most likely bind at the same site, but this may not be the case. If they do bind at the same site, and you've maxed out your body's amount of Equipoise for your level of androgen receptors, then testosterone will never bind to any of the androgen receptors because the affinity is greater for Equipoise. But does this mean anything more than that? No. So for that I have to explain something else, which is that there is something called an affinity to a receptor, which means how much a ligand is something that binds to a receptor, like Equipoise or boldenone. How much it binds, with what affinity it binds to a receptor. And then there's another thing called efficacy, which means by which efficiency or efficacy it causes response elements that depend on that receptor's agonism or antagonism to be activated. So what you really care about is not the affinity for a receptor, but the efficacy. So there are response elements like in the androgen receptor, there are certain standard things that will happen when the androgen receptor is agonized, and that if you judge based on that, you can tell how powerful a certain drug is at the androgen receptor. But the affinity itself can be misleading. You can have a very strong binding affinity with a weak response element. So we don't really know much from this, and that's why it may be contradictory to you for those of you that have tried boldenone and said, well, I don't feel very androgenic on it, but you're telling me it's more androgenic than testosterone. It could be because it has less of an efficacy. So I didn't mean to go into too much detail about this, but I think it's worthwhile. Another thing to mention is that, so this was quite interesting. It has a lower affinity for the progesterone receptor than testosterone, 1/4 lower than testosterone. And testosterone's affinity for the progesterone receptor is quite low. It also has more than 100 times less affinity than nandrolone or deca, which makes quite a bit of sense. Deca agonizes the progesterone receptor not very strongly compared to progesterone, not nearly as strongly as some of the compounds related to a compound called MENT, for example, but it does agonize the progesterone receptors, which, by the way, has effects in the body. So agonism of progesterone receptors, probably I didn't include a citation on the blog post, but agonism of the progesterone receptors causes muscular development in women, whereas agonism of the estrogen receptors does not. Moreover, agonism of the progesterone receptor can be desirable in other kind of senses. For example, in the brain, agonism of the progesterone receptor causes a synthesis of myelin. Myelin is a compound, a lipid-rich compound that covers the axons in the brain that send neurotransmitters around. So you want some agonism of the progesterone receptor. The problem is, for the man, a lot of the progesterone is produced in the gonads. So when you go on hormones, your gonads are no longer producing progesterone. So unless you're replacing the progesterone in some kind of way, or unless you're taking a drug that agonizes the progesterone receptor, you're not going to get these effects. You're neither going to get the muscularity effect or the natural effects of progesterone agonism. And this is quite significant. You'll see why in a second. I have a theory for why Equipoise, we'll talk about it in a second. Another thing to mention is that it binds, oh, by the way, the progesterone receptor I was mentioning just now was actually a bovine progesterone receptor, which means it's a cow's progesterone receptor, whereas the androgen receptor was a human recombinant androgen receptor. It doesn't matter that much. The sequence of the progesterone receptor between cows and men is more similar than we would think. At least it's more similar than the sequence differences between androgen receptors and progesterone receptors in men. Not finally, but one other thing to mention is that it also binds to sex hormone binding globulin more than testosterone, actually 50% more. And this is not very important, to be honest with you. And the reason why is you can just take more Equipoise, so it doesn't really matter. But another thing to mention is that, very interestingly, boldenone is produced naturally in a number of organisms, a number of mammals, including cows, horses, I think, a bunch of different animals. The reason why they know this is that researchers were trying to determine tests to check for boldenone being used for the treatment of produce, like meat people are eating. And while doing so, they found out that some of the natural animals that were not taking boldenone tested positive for the tests. So it seems it depends on some microorganisms that the animals have inside them, as well as what foods they're eating, where testosterone can be changed in such a slight maneuver where it becomes boldenone. It's actually only one change to the molecule that causes boldenone to be created. So that's my notes from the research. Now here's what I have to tell you from myself personally. First of all, for some reason, Equipoise keeps being produced in it's called an undecylenate ester. The undecylenate ester is extremely long-acting, much more long-acting than for example, enanthate. And we know colloquially from people that have gotten tested, I don't know if this is in papers, to be honest, I've never looked, but I know people who have gotten their blood tests tested frequently. And their testosterone, if they're injecting testosterone and enanthate once a week, it only maximizes in the body in about 6 weeks. So that means that undecylenate of Equipoise, there's also testosterone undecylenate, but they don't produce it anymore, by the way. But boldenone undecylenate will probably not reach peak concentrations if you're injecting it once a week before at least 10 weeks. So most people, when they do like what they call blasts or cycles like that, they tend to do something like 12 weeks or less. This means you won't even reach your max before your cycle ends, probably. We don't know exactly how long that'll be. And that's significant for anyone that's trying to do something short term, especially if you're trying to do something where you want your body not to adapt fully to it. So you don't want, for example, androgen receptors to downregulate. Now there is, I knew that Dan Duchesne thought that androgen receptors don't downregulate. I actually found a paper from 2000, probably again, it's not in my notes, but I found a paper from 2000 showing that there was some evidence that androgen receptors in some contexts may upregulate. But I don't believe they do from my own personal experience and everybody that I know. If you take high enough doses, you maybe in the long term get a better response if you go off, but you get what's called there's a word for this in medicine. I forgot what it's called. Maybe someone can comment below. I forgot the word. It's a weird word with a PH or an F. But anyway, what it means is that you get diminishing marginal returns. And not just diminishing marginal returns, but it's so diminishing that it shows that there seems to be some reaction in the body that, you know, lessens the amount that the hormone will affect you in a positive way. So, okay, this was very long-winded. The point is, it's a very long ester, usually, and you find it in a very long ester. It's not very helpful in my opinion for that reason. Another thing is that it's what they call a dry compound, which means it doesn't cause you to bloat. Why not? Because to my knowledge, it does not, well, of course, it doesn't, basically it doesn't cause you to bloat because it does not allow, it cannot be aromatized to estrogen. It does not allow estrogen to upregulate in some kind of way that we know of. It also does not agonize progesterone receptors, which means because it doesn't agonize progesterone receptors much, estrogen receptors don't upregulate. See, when you have higher progesterone, estrogen receptors upregulate. That's one of the consequences of progesterone's agonism of the progesterone receptor, the nuclear progesterone receptor. So, this means that it's a very dry compound. If you don't take testosterone with it, you're not going to gain very much water weight. So people like it for that reason. I'm just commenting on things now that I find relevant before I tell you my opinion, which really comes in the next point. So, basically, why did people like this compound? Mainly because it was dry, what they call dry. You know, it didn't cause them to be puffy. It doesn't, for most people that haven't removed their glands, it doesn't usually cause them to get glandular tissue around their nipples. And the other reason that they like this hormone is because of endurance. So what happens is this. So by the way, again, this is probably not in my paper, but there is evidence that testosterone increases hematopoiesis, which means the creation of red blood cells in the serum. It increases hematopoiesis through a erythropoietin dependent effect. Erythropoietin is the main hematopoietic molecule in the body that's also called EPO, and through a non-erythropoietin mediated effect method. So testosterone does that. Now, we don't know exactly what Equipoise is doing, but it is increasing hematopoiesis tremendously more than testosterone. Everyone has seen this. We've seen this personally. I don't think there are any studies on this. There may be. I didn't go too much into details of the studies because it's boring and there's not very many studies. But the point is, I don't think there are. It's doing something. I think it's probably increasing erythropoietin more than testosterone is because it's such a powerful effect. It's probably going through erythropoietin. The point is, it increases red blood cell count tremendously. The effect of this in terms of performance is that people get better endurance in the gym. And this is very visible. Within like 3 or 4 weeks, you don't get out of breath as much. You can do your sets more. It actually improves your performance significantly in a similar way to what erythropoietin would do. The problem with this is the effect is directly a consequence of having more red blood cells, which means you cannot get the endurance without getting the blood thickening element. If you try to do phlebotomies, you will reduce your endurance. Now, back in the day, this didn't matter so much because the only way people could increase their endurance was either through erythropoietin or this, or maybe some other molecule that was hematopoietic. But that's not true anymore, mainly because of cardarine. To my knowledge, cardarine is the only molecule that really tremendously increases through its agonism of the PPR delta or beta receptors, tremendously increases endurance. I mean, there are other molecules that people say increase endurance, but it's not that great. Not that great of an effect. The other thing that cardarine does is it does it immediately. This doesn't do it immediately. So you don't need to take cardarine every day to have more endurance. In fact, you should never do that because there's a lot of reasons that it could cause cancer development. But you could do it in the short term if you need to. Or you could do it only on workout days. Or you could do it only on your leg workout day or something like that. You can't do this with this. And you can't divorce it of the hematopoietic effect. So what does that mean? That means it's true it increases your endurance. But it does two things. Number one, it makes your blood pressure higher, which means that your heart, just because of the blood pressure being higher, so what it does, it thickens the blood. Because it thickens the blood, immediately the blood gets, like the blood vessels get tighter. When they get tighter, there's more force needed to push the blood through the body. So your heart gets tired. The other thing it does is it increases the likelihood of your blood to clot, which people may know more about this now because a lot of bodybuilders have recently gotten severe blood clots. I don't know if this has anything to do with the coronavirus, but unfortunately, forgetting his name, but one of the top bodybuilder coaches got a blood clot in his heart. He's a very nice guy. I feel very bad for him. I hope he gets better. And it damaged his heart potentially permanently. So people understand the danger of blood clots. Now, if you're much younger, or if you're someone who's naturally anemic, this might not matter that much to you. But it's still a concern. Basically, you could end up damaging your heart for life if you get the blood clot in the wrong place, or you could get a blood clot in your brain and get a stroke or something like that. But more important than that, what's definitely going to happen to everyone is that their heart is going to pump with a stronger force every time it pumps, because imagine your blood is getting less viscous. It's becoming more sludge-like. So you have to work harder. What does this do? This causes the heart to grow, but it also tires the heart. So it's great for you to go, for example, and do HIIT, high intensity interval training, and raise your heart really fast and then lower it, because it allows your heart to get, basically it exercises your heart so that your heart is able to go faster when it needs to, in case it ever needs to, so you don't get a heart attack, hopefully. But it's a different thing when your heart has to work harder at resting rates. So if your resting heart rate is high, or if your blood is sludge-like or less viscous, your heart gets tired over time. And other than viruses, this appears to be the main way that people experience heart failure in later life and have to get heart transplants. Other than congenital problems with their hearts, of course. So it's not a good deal. Basically, you can't deal with the effects on your heart unless you give phlebotomies very frequently, which some people think they can, just donate blood to the Red Cross whenever they allow them to, which I don't know how often that is, maybe every month and a half or something like that. That's not enough. Because if you do that, what happens is you get a cyclical nature in this sludge-like, non-viscous effect in the blood. So over time, your heart has to work really hard, and then has to work less hard, and then has to work really hard, and then has to work less hard. Other people are concerned that if they donate blood frequently, the blood starts to create red blood cells faster. That is actually true, but it's not that much of a concern, because as you can tell with people who have congenital conditions in which they produce too much iron, for example, if they give blood frequently enough, they still maintain lower iron levels. So and their blood doesn't get too sludge-like. So basically the body does adjust. It probably upregulates erythropoietin synthesis, but it doesn't do that to an endless amount, at which point there's no point in giving blood or you're in some danger. So that's not so much a concern. The concern is that you have to give blood probably at least every 2 weeks. That you have to do it regularly enough that you're not going through sludge levels and then watery levels and then sludge levels and water levels, because then you're doing something to your heart that most people don't do, and you don't want to do that. So you probably have to give blood every 2 weeks. You can't do that in the US easily. The blood donation places have databases with your social security number. They keep track of you. So you end up having to do your own phlebotomies. Now, I'm a person who really wants to do phlebotomies, and I've been trying to delay it for a month and a half or so, or even 2 months, because I don't want to do it. It's actually very unpleasant to have to poke yourself in one of your veins and pull out enough blood to make a significant impact, especially because you need something that has suction. And this is where it gets really confusing. You need like a blood bag that has suction, which you can order online. But I'm getting confused because, this is a bit off topic, but as the blood fills, you get less and less suction. So you have to squeeze your hand and do all this kind of weird stuff, and it takes a long time to get enough blood out. So it's really, that part is clearly not worth Equipoise. I mean, it's just not worth it. So another thing I want to mention about Equipoise, which a lot of people notice. Now, there was a rumor online on some threads a while ago that Equipoise increased anxiety in some people because it had some effect at increasing one of the estrogens. Now that I know much more about the brain years later, I think this is not possible. I have a strong suspicion for what Equipoise is doing. Now, by the way, there's some evidence that Equipoise, for example, even increases the activity of the acetylcholinesterase enzyme, which may be why it reduces memory and learning in some animal studies. So it does things in the brain. Probably testosterone does that also. I just haven't read studies on acetylcholinesterase with testosterone. But the important thing is this. We know from my video on testosterone in the brain that one of the major outcomes of using androgens in the brain, especially when you're not using estrogen at the same time, or when you're not using testosterone that can aromatize into estrogen, what ends up happening is that you get a downregulation of serotonin receptors. One of the main reasons you do that probably is because estrogen exerts its effect over to serotonin receptors, and women have more serotonin in their body and more serotonergic activity. It's quite likely, though not proven, and I'm not sure if this is true, but it's likely that you need a level of estrogen to maintain serotonin receptor activity in the brain. It may be. So it may be possible that serotonin receptors downregulate in the absence of estrogen. But what I think happens probably is people are taking low dose testosterone and high doses of Equipoise. People regularly take 2 grams of Equipoise or a gram or 3 grams of Equipoise. People do that. I've tried that, but not 3 grams. But you have to take a large amount of it because it's quite, the effects are quite weak otherwise. So when you do that, probably you're not taking much testosterone. And so you have less estrogen in your brain compared to the effect of the androgen. So probably what's happening is a couple of things. Number one, you probably have less serotonergic activity. So your anxiety may actually be coming from less neurogenesis. It's been shown in studies, and I think I cited this in my serotonin series. If not, probably be in the next series on GABA. But basically, it's been shown that when you inhibit neurogenesis, aside from serotonin, nothing to do with serotonin, but when you inhibit neurogenesis, I think it's by antagonizing the TRKB receptor that activates brain-derived neurotrophic factor. When you stop neurogenesis in animals, they develop anxiety directly. So I don't know exactly how that works. Nobody really knows, but they develop anxiety. So it may be possible that it's an effect of reducing neurogenesis in the brain. Another thing that it may be doing is that, so your gonads are no longer producing much progesterone, which means although progesterone is produced in the brain also, it means probably overall you have less neurosteroids, and in particular you probably have less allopregnanolone. Allopregnanolone is a metabolite of progesterone, and it is the positive allosteric modulator of the GABA A receptors, which are the receptors of the brain most tied to anxiety. So probably you have less activity of the GABA A receptors because you have less allopregnanolone. You can probably work around this by taking micronized progesterone, but if you did so, then there's probably no reason you wouldn't take, for example, DECA or something else that may agonize the progesterone receptors instead of Equipoise in the first place, since you have to give blood every 2 weeks anyway. But so that's what, basically my point is, Equipoise is sort of a useless drug, especially after the advent of cardarine. Before cardarine, maybe I understand why people would take it. People who either didn't know about the effects on the heart or didn't care may take it, but cardarine is more effective for that purpose. And erythropoietin on its own, if you really don't care about your health, especially the hematopoietic versions of the erythropoietin, because there are versions that don't increase the red blood cell count. You can learn about them on my blog. I have a series about EPO-derived molecules like EPO peptides. But erythropoietin has effects on angiogenesis that, for example, BPC would have, or TB500. It has effects on growth. It does things like that in addition to the red blood cell activation. Even if Equipoise is doing that through erythropoietin, you would, and if you just really didn't care, you would just take erythropoietin directly so you could manipulate it yourself instead of having the androgen and the erythropoietin together in one molecule that you can't separate. It's always better to have your things separate so you can fine-tune them. So basically, maybe originally when there wasn't, even then, people would rather take recombinant erythropoietin. Basically what I'm trying to say is Equipoise is a useless, inefficient drug. If you want to be healthy, it's completely against your incentives because it does a lot of things. It doesn't convert to estrogen, so you don't get the protective elements of estrogen. It doesn't convert to progesterone, so you have less allopregnanolone in your brain, so you're more likely to get anxiety. It causes the hematopoietic effect, so if you care about your health, you have to donate blood every 2 weeks or so, or maybe more than that even. It's just not a great drug. Now, with that said, a lot of people have favored it. Famously, I have no confirmation of this, I didn't hear it personally, but famously, the Mr. Olympia of the 1980s, I can't remember his name, used to take it a lot, the guy before Dorian Yates. But again, he quit when he was 31 or so. So that guy never really went through the potential really serious harm long-term of taking Equipoise. He was known to take large amounts of it. Probably it's just because people knew less back then. And there's also someone famous at Westside Barbell, I won't say who specifically because I heard this through someone who knows him, but that really likes Equipoise as well and takes high doses of Equipoise. But for that purpose, if you're really using it because it's dry and you're using it because you don't want it to convert to estrogen, you have other molecules like most notably Primo, which would be favorable, I think, overall. In fact, combining Primo, if you didn't care at all about what was happening in your heart, combining Primo with erythropoietin would probably be a better bet than taking something this long acting that you can't control, that does both, and you can't control the individual mechanisms and fine tune it the way you want. Anyway, for those that care, this is my opinion on Equipoise. I think it's better left to the horses. It's definitely not something worth using. I've used it extensively in the past. I enjoyed it. I got mild anxiety only when I was older, which would make sense. You have less neurogenesis when you're older, and some things work a little differently in the brain when you're older. When I was younger, I didn't notice any anxiety, but you know, for the reasons that I mentioned about the heart especially, it's just not worth it. And I think you should skip this one. I don't know which one I'm gonna do next. If you guys have a recommendation, let me know down below, and I'll probably take whatever is most voted to discuss next week as a PED. Thank you for listening. I'll see you next time.